You can unmute yourself, you could put questions in the chat, whatever you need. If I go too fast, just tell me to slow down. Like I'm okay with that. Like I won't bite, I promise. Let me open up the chat too. So we have that. All right, so we're working with double angles still. So again, we're using the formulas that I had shown you guys yesterday. And so those formulas are going to be the same ones on our formula sheet. So let me just point out the ones that we're going to be focusing on. Again, it's double angles. So we're focusing on these ones right here. So these are going to be where I'm pulling all the formulas from. So we've already done sum and differences. We've worked with the co-functions. And then we have our double angles, which is today's lesson. So today is going to be going over problems from your assignment. So let's go ahead and let's rock and roll. So when I look at these right away, I can tell that this is going to be one that I have to do a triangle because they gave me this fraction here and they told me my quadrants. Different than when they give me something that's in degrees or radians, then I know I'm using my unit circle. So these are when we have to create our triangles. So it asks me, what is sine of 2x? So I know that sine of 2x from my double angle formulas is equal to 2 sine of x cosine of x. Now remember, sine of 2x is not just saying like you double this number, or if this was a cosine, you don't just double that number. That's not what it's saying. It's a double angle. So, all right, I look at what I'm given. I know that cosine of x is a negative 1/4. This piece right here is a negative 1/4. Perfect. I know that this is going to be a 2. My problem is I don't know what just sine of x is. So I've got to figure out that sine of x. So I want sine of x, and we know cosine of x is equal to negative 1/4. And I know that tangent of x is less than 0, this piece right here. What does that mean that tangent of x is less than 0? Well, if it's less than 0, then it has to be a negative number, right? So if it's less than 0, we know that tangent has to be a negative value. And I use this information to help create my triangle. This is my my adjacent over my hypotenuse. So if I have a right triangle, my adjacent side is going to be a value of 1. My hypotenuse is 4, then I need to figure out what my opposite side is because I want sine. So if I want sine, sine is going to be opposite over my hypotenuse. So I could go ahead and I could do Pythagorean theorem. 1 squared plus my opposite side squared is going to equal 4 squared. 1 plus my opposite side squared is equal to 16. My opposite side squared is equal to 15. I take the square root, so that opposite side is going to equal the square root of 15. So I know right here this is going to be the square root of 15 all over my 4. But I'm not done because I need to know, is that a positive or is that a negative? And that's where this idea of this quadrant comes into play. I know, so all students take calculus. I know my cosine was negative, right? Well, if it's negative, then it can't be in quadrant 1 because they're all positive. And my value can't be in quadrant 4 because that's where cosine's positive. I also know that tangent is negative. So in quadrant 2, sine is positive. In quadrant 3, tangent is positive. So that means that we can't be in quadrant 3 because I know tangent has to be negative, which means I'm going to be in quadrant 2. So this is a positive right there. So that's going to be a positive. So I could go ahead and plug in then that my sine value here is going to be a positive square root of 15 all over 4. And then I just multiply everything. That's the hard part, is figuring out that missing piece. But once I get that, I could go ahead and just multiply everything. And I have the same thing as 2 over 1 if you prefer to look like that. If you wanted to simplify, you could. If you wanted to wait till the end to simplify, you can. So 2 times the square root of 15 times a negative 1 is negative 2. Negative 2 square root of 15. 4 times 4 is 16. And if the coefficient and the denominator have something in common, then I can simplify. So 2 goes into both of these. So my answer is negative square root of 15 all over 8. Negative square root of 15 all over 8. And I'm done. So don't forget to check what quadrant you're in. That's where you guys make the biggest mistakes. Notice they try to trick you. They have a positive and a negative. If you didn't do the right sign, then you would get the answer wrong. You could. You might guess right, but. All right. This one says, write the given expression as a single trig function, because right now it has a sine and a cosine, so they wanted to write it just as one. And sometimes when we look at this, it's easier for us to put this in terms of an x value. So what if I say that x is my 3 pi over 8? The reason why I do this is because visually it's easier for you guys to see if I have 2 sine of x, cosine of x. So if I match it up with my formulas, 2 sine of x theta or cosine of x, I can see then that it's going to be sine of 2 theta, or in this case, is equal to sine of 2x. So again, it's easier for you guys visually sometimes when you get rid of that actual value and put a variable in to see which one does it match up to. So I already know then that this is my 3/8 is this x value. So I'm looking for sine of 2 times 3 pi over 8 is going to be equal to, I could write this as 2 over 1. I could simplify. 2 goes into 8 4 times. So that becomes a 1. So it's going to be sine of 3/4 pi. And guess what? What is so awesome about that value is that that would be on my unit circle. Oh, there we go. So when I go over here and I look for my right answer, I didn't ask for you to solve it. It just asked for you to simplify it. So I look over here and here we go. My sine of 3 pi over 4 is right here. And that's my answer. I'm done. So, but the reason why we would do this is because those are values on my unit circle. 3 pi over 4 is where 3 pi over 8, that's not on my unit circle. So sometimes it helps us to work backwards so we could find the exact value. All right, I'm gonna flip it over. Another triangle one. I know it's triangle because I have this fraction here. It's my sine of x is equal to something, and it gives me my quadrant. So again, another triangle, and this is a tangent. This is a tangent one, which means we're gonna have a fraction. That's okay, it's not the end of the world. Just take it piece by piece. So what we wanna solve for is tangent of 2x. So from my formula sheet, I know it's going to be 2 times tangent of x all over 1 minus tangent squared of x. And if you remember, I'm just going to make this little note up here just to remind you guys, like the more you guys see it, the more you guys will remember that this tangent squared of x is just saying tangent of x, that quantity being squared. This is equivalent notation. You're not squaring the x. That's why they put it in front of the x. If they put it behind the x, then it looks like you're squaring that value of x. So that's why they write it like that. All right, so let's see, what do I know? I know sine. I know what quadrant cosine is positive. I know cosine has to be positive. I need tangent. So they didn't tell me what tangent is, and that's the one I need. That's okay, because we can solve for it. We've got this. So we know sine of x is equal to a negative 1/3. I know that cosine has to be greater than 0. So cosine of x is greater than 0. If it's greater than 0, then it has to be a positive value. Has to be a positive value. We want tangent of x. So we need to know what is our opposite side over our adjacent. So I draw my triangle. I have my opposite over my hypotenuse. So I have a 1 and a 3. I need to figure out this missing side over here. No big deal. My adjacent side is going to be 1 squared plus my adjacent side squared is equal to 3 squared. 1 plus my adjacent side squared is equal to 9. My adjacent side squared is equal to 8. I take the square root and I have that my adjacent side is the square root of 8. But I look up here and I notice there's no square root of 8. That's because this can be simplified. I don't remember, it was like yesterday or the day before, we came across this one and they left it like this, and then sometimes they simplify it and it's kind of crazy because they're not consistent. So square root of 8, remember, is 2 times 4, which is 2 times 2. So I could pull out a pair of 2, so I could pull out a 2, but this 2 still stays under the radical. So this is the same thing as 2 square root of 2. So this is 2 square root of 2. The other piece I need to figure out is what quadrant are we working in? So all students take calculus. These tell me which of the trig values are positive. So I know sine has to be negative. Sine has to be negative, so it can't be in quadrant 1 because that's where they're all positive. It can't be quadrant 2 because that's where sine's positive. And I also know that cosine is positive, and cosine is positive out of these two that are left. Cosine is going to be positive right here in quadrant 4, so I can't be in quadrant 3. I have to be in quadrant 4 because that was the only one on the two left where cosine was positive. So if I want tangent then, and I'm in quadrant 4, my tangent value is going to be a negative. My opposite side was 1, my adjacent side was 2 square root of 2. Lot to take in, right? So let's plug into my equation here. Let's plug everything in. So I have 2 times my tangent, we said, is this piece right here. You could choose to rationalize this. I don't know what's better. If I rationalize this, let's look at it rationalized. So it'd be 1 over 2 square root of 2. And I would multiply both square root of 2 over square root of 2. So when I do this, I end up with negative square root of 2 over square root of 2 times square root of 2 is going to be a value of 2, square root of 4, which simplifies to 2. So I end up with negative square root of 2 all over 4. This might be easier to work with. So I'm going to go ahead and use this value. You could choose to use this, but it might be harder to work with. And so I'm going to choose to work with this. Doesn't make one way better than the other. It's just a preference. And in the end, you might have to rationalize anyways. So I'm going to go ahead and I'm going to choose this value. These two are equivalent. This is just rationalizing. It means that there's no radical in the denominator. So I'm going to do negative. See, my tangent of x is negative square root of 2 all over 4 divided by 1 minus a negative square root of 2 all over 4 squared. Well, this is kind of nice because my 2 can simplify with this square root of 4, and this can become a value of 2. So I end up with negative square root of 2 over 2 divided by, this is going to be 1 minus the square root, negative square root of 2 squared. That's going to make us the positive 2, right? Because the square root of 2 squared is square root of 4, which simplifies to 2. So this goes here, but it also goes to my denominator, which is going to be 2 over 16. And I'm going to go this direction. I'm going to try to squeeze it in. So now I have negative 2 square root of 2. This could simplify to an 1 over 8, right? But I want to write this as one term. So in order to do that, I need a common denominator. So I'm going to change this 1 to 8 over 8. 8 over 8 is still 1. So this becomes 8 minus 1, which is 7/8. I still have this ugly fraction. So this is what we call a compound fraction. So I'm going to multiply by my reciprocal. So I have negative square root of 2 over 2 times the reciprocal. So if I'm dividing, remember you multiply by the reciprocal. 2 goes into 8 4 times, so I end up with negative 4 square root of 2 all over 7. And that's my final answer. So this one took a little bit of work, but we got to it. This was a great review of your fractions, simplifying fractions. So this is all stuff that you guys know how to do. This is using your right triangle, SOHCAHTOA. And here, you're just simplifying fractions. This is the new piece, but that's the easiest piece because you're given the formula. Everything else is stuff you already know. And sometimes I take it slow for you guys because just remembering and going through the steps. And then sometimes you guys struggle with it for all bunch of weeks. And then all of a sudden you guys are like, oh, I get it. That aha moment. If you guys have questions, again, make sure you let me know. And then we're to our very last problem. And this is just explaining what's going on from step to step. So if I go from here to here, what's happening? Well, an x plus an x gives me that 2x, right? It's just addition. Don't overthink it. Luckily, too, they give you guys a drop-down menu so that can help you with your decisions. And this right here, going from here to here, if I'm adding these two terms, remember that this is just going to be our sum identity. So if you guys remember our sum identity, so if I'm adding an x plus an x for cosine, so cosine and it would be a plus, then it would be my cosine minus my sine, and look, cosine minus my sine. So that's all this piece was. So again, don't overthink that. So this is going to be my, I think they call it your cosine sum identity because we are working with cosine. But again, it's a drop-down menu, so it's either sum identity or cosine sum identity. So you only have so many choices that you'll see which one is going to be it. And then how do I go from here to here? Well, cosine times cosine is going to be a cosine squared. And so you could have done like a product, but I think the option they give you is just to simplify. So that's where this piece comes from. This is telling you then that cosine squared of x minus sine squared of x, that is equal to your cosine of 2x, your double angle formula. Remember, for cosine, you have 3 options. You can use any of the 3. They're all going to give you an equivalent answer. So this is all stuff on your assignment today. I wish you guys luck on it. We'll go over no school Monday, so enjoy the 3-day weekend. And Tuesday, we will go over the quiz. So hopefully if you're behind on anything, get caught up. Progress reports will be going out soon. So I will update grades on Tuesday, and we'll go over problems from the quiz on Tuesday for this section. Otherwise, you guys enjoy every minute of your 3 days off.
Everybody have a good weekend.
Bye, dear.
Thank you.
You're welcome.
Thank you.
You're welcome. Bye.